Okay, it seems like it is recording. I'm just worried that it doesn't show any time moving, but let's hope it will record. Okay, can you guys see the presentation? Okay, cool. Okay, so I'm just gonna skip to the part that we're gonna start today. So basically, on Monday we nearly stopped at the probability and the introduction to that. We did one question, so I just thought that we will continue with this, and if we have enough time, we can start with the next one as well. Okay, so once again, this one, what they're giving us here is a joint probability. So let me just, so if when I see this in the exam, I would first start completing, so I know that the probability of B1 will be those two added, so it's 0.7. Okay, obviously here was a mistake. That should have been B2, otherwise we are looking at the same thing. So let's just make it like that. So the probability of B2 is those two added, so it is 0.3. Then the probability of A1 is those two together, so it's 0.6. The probability of A2, those two together, and it's 0.4. Okay, so with that, was nearly looking, okay, so probability A1 we've done, it's correct. Okay, we are looking for the incorrect one, so we need to continue. Probability of B1, 0.7, so that is correct. Okay, the other ones we need to see if there is anything that we need to get in the table. So what is the probability of A1? And let's go to another color. So A1, and let's draw it to it. So A1 and B1. So A1 and B1 is sitting there, so 0.4. So that is also correct. Okay, let's see probability of A1 and A2. Probability of A1 and A2 will be those two together, which is 1, so that is also correct. Probability of B1 and B2 wait. Okay, so sorry. So I am reading it wrong, and how easily one can make a mistake. So that is definitely not So what's the probability of A1 and A2? And what do you guys say? We are still only a few, so what's the probability of A1 and A2? Any guesses? Okay, so can A1 and A2 happen at the same time? Okay, so A1 and A2 can't happen at the same time. So A1 and A2 is mutually exclusive. So A1 and A2 needs to be equal to 0 and not 1. If it was A1 or A2, that would have been equal to 1. Okay, so if it was A1 or A2, that would have been equal to 1, but you can't get a A1 and a A2, so the probability is equal to 0. So that will be the one that is wrong. And you can see probability B1 and B2 very similar to the top one. You can't get it, so it is 0, so that one is correct. Okay, so nearly I made that mistake as well, just to say, oh, but it is one and the other, but it's actually can the two happen together. Okay. Questions on this one? Okay, so let's just continue to the next question. So with this question, you can see that you first need to nearly calculate the missing values, and then they ask you to calculate what's the probability of A and C. So what is the probability of those two happening? Okay, so basically I don't think you need all of the information. So firstly, you need to work out what that value will be, and that is nearly straightforward. So if a total is 45 of that row, that is 51, so this value will be 14. So then if I need to say complete the missing values, calculate the probability of A and B, so you basically, what's that probability? So it is 14 divided by the total, which is 70. And 14 divided by 70 will be 0.2. So option 5 will be your answer. Okay, can anybody else here that I know it's not on my side that can everybody else here? Okay, cool. I'm still worried that I don't see the meeting. I know I've been recording, but there's no time going on, so I'm still worried that something is wrong with this session, but we'll see at the end if I can download the video as well. Okay, so for this one, you actually didn't need to waste your time in calculating those. because for this question, we basically didn't need it. Oh, is that the one when that will translate or pick up what I am saying? Is that what the live captions does? Okay, cool. As long as I don't talk in a different language, and hopefully my English is good enough for it to pick it up. Awesome. So if that works, okay. Okay, so this is something that I nearly see will happen in the exam, is something like this, that you will get nearly a table with maybe some of it not filled in, or it can ask you to do some calculations. What I think can also happen is that sometimes they give you much more information. Yeah, no, that's why I'm worried what I'm saying and some other words come out. So yes, what for me is interesting with these types of questions is that sometimes they do give you a lot of information, and sometimes too much, that it nearly confuses you, because I know if I was in the exam, I probably would have wanted to complete this table first. I probably would have wanted to to fill in all the missing detail. And then I will probably have read the question, and then I see, okay, that it's actually only that one value that I need. It's different if the 70 was also not included and you nearly needed to work out what a total is. Then it's a bit different as well. So I think also nearly the tips that I want to give you is nearly first read the question, and then you nearly say, okay, but I need the value of where the A and the C is. So I need that. If I need that, I need the total. That's the only two things that I complete on the table, and then I can get my answer instead of doing everything, and you don't need all of that information. Okay, let's go to the next question. And I think again a bit of, so you'll see some of the questions is how to work things out. Other ones are again some theory behind it. And I think this is, if there is theory in this exam again, it will be more theory that test if you understand the concept, instead of just saying correlation means blah blah blah, because that you can actually Google or you can use the textbook for. So I think that is very important. So let's look at these sets of questions. So which one of the following statements is incorrect? Okay, so the first question, or the first one, is the probability refers to a number between 0 and 1 which expresses the chance that an event will occur. Okay, so that is correct. So we know, if we even look at the normal distribution curve, it is a probability between 0 and 1 that something will happen. So that is correct. An experiment is an activity of measurement that results in an outcome. Okay, so that is actually somewhere in the textbook. They give, or even in the study guide, they give you what the definition of experiment is. So that one is also correct. If the event of interest is A, and the probability that A will not occur is the complement of A. So again, that is true. So how it is normally written is, if it's the probability of A, the complement of A is, they sometimes write it in two ways. So that is the complement of A, or they can write it sometimes as basically that sign that says not A. Okay, so there's two ways to write it, even if I brought that in, but that is also correct. And how you get that is basically by saying 1 minus the probability of A. So if a probability A was 0.6, the complement of A will be 1 minus 0.6, which is 0.4. Okay, so let's look at the next one. When events A and B are independent, then A and B is equal to A times B, and that is also correct. When it's mutually exclusive, A and B will be equal to 0. So when it is mutually exclusive, it will be A and B will be equal to 0. Okay, so let's look at the last one. With sex of students, males and females, cannot be used as an example of mutually exclusive. So yes, let's not go into that. Will probably change, but when this was set up, you could only be male or female. So I think they probably need to rethink a bit of their questions. But it is nearly the same as you cannot at one moment be in one province and in another province. So I think so mutually exclusive just shows that. So you can't have at the same time blue eyes and green eyes. So I think that just shows it is mutually it is mutually exclusive. So because they say it cannot be used, that is the one that is incorrect. Okay. So in this method, they nearly were asking you to understand what independence mean. They ask you basically what the complement means. They, in a sense, ask you that you know what the range of the probability is. They ask you what mutually exclusive means, and then they have thrown in one of the things. So they could have asked you what a sample is. Here they ask you what the experiment is. They can ask you what the event is. So any of those kind of things they could have thrown in as well. So that nearly, in that one question, it nearly sums up everything about what you need to know about probability nearly. Okay, so another way that they can ask it is they can tell you, well, there's a probability of a one event and there's a probability of another event. So here, the first one is probability of A, and then there's a probability of B. And they ask us which one of the following statements is incorrect. Okay, so now it's nearly, we need to work it out from the start. If events A and B are mutually exclusive, then probability of A or B is equal to 0.8. If events A and B are independent, then probability of A or B is equal to 0.8. If events A and B are mutually exclusive, then probability of A given B is 0. So if events A and B are independent, then probability of A given B is equal to 0.5. If probability of A and B is equal to 0.2, then probability of A or B is 0.6. Okay, so not really anyone that is easy or just to eliminate, so I'll start at the top. So basically, to get probability of A or B, oops, just write that better. Probability of A or B is equal to probability of A plus probability of B minus probability of A and B. I'm just going to write it as that. Okay, so we know that the probability of A is 0.5. We know that the probability of B is 0.3. So out of that, we already know that it's 0.8. Okay, so if events A and B are mutually exclusive, that will be 0. 0.8 plus 0 will be 0, so that one is correct. So if it is mutually exclusive, it will be 0.8. If events A and B are independent, so when it's independent, the probability of A and B we get by saying it is probability of A times probability of B. Okay, so it is minus 0.5 times 0.3, which is 0.15, which gives us 0.65. So then we know that that one is the incorrect one. Okay, let's just continue with the rest as well. I think it is important that we just know how to do it and how to write it. So when I see this, how I normally remember to write it is it's A given B, but the formula is when probability of A and B. So I nearly remember it as probability of A and B divided by the probability of the last one. So divided by probability of B. So if it is mutually exclusive, A and B will be 0. So it doesn't matter if you by what number you divide it, 0 divided by 0.3 will be 0. So that will be correct. If A and B are independent, we use the same formula of A and B. So then it would be, the A and B would have been the 0.15. And we need to divide that by the probability of B, which is 0.3. And 0.15 divided by 0.3 will give me 0.5, which is, again, correct. Okay, and this one was if probability of A and B is that. So if it was, then we still know the probability of A plus the probability of B is 0.8 minus the probability that they give us, that is 0.2. 0.2, and that would then give us 0.6. Okay, so that one would have been correct as well. So the one that are incorrect are the independent one. Okay, quickly ask questions if there is any. Just want to get a check-in from you guys, that because this was quite a lot and went through it very quickly. Are you guys happy? Just give me a thumbs up, thumbs down. Need to show something again. There's one more, so okay, so let's do the last one, and then we can see if we need to look at something else as well. Okay, so in this question they tell us two events A and B are independent with probability of A and probability of B. Okay, so the first thing I would like to write that just as a decimal. So that is 0.25 and that is 0.75. Okay, so they tell us it is independent. So probability of A and B is equal to 0.25 times 0.75. Okay, because they tell us it is independent, we can automatically say that that rule will follow. So that is equal to 0.1875. Okay, then that is interesting. Okay, then the rule that I normally follow, what is the value of the probability of A given B? So it is the probability of A and B divided by the probability of B. So that is the 0.1875 divided by the probability of B, which is 0.75. So that answer would be 0.25, which is option 2. How you can nearly look at this as well is, if we know it is independent, then this probability will always be equal to the probability of that one. Okay, we saw it here as well when we talked about if it was independent, and we could have seen with this one as well, it is basically the probability of the first one, the probability of the A. So when it is independent, you can actually automatically say, you can go through this whole calculation, but what it will be is it will be equal to the probability of that first letter. And that first one was the 0.25. Okay, so that was a few questions on probabilities. So let me just get a feel of where you are, understanding it a bit better. Must we look at one or two more, or can we go on to the next section that we will definitely not finish, but we will start with discrete probability, hopefully binomial, but we will definitely not finish Poisson as well. So I think we will probably just do discrete. Okay, are you guys happy that I continue with the next section? You guys are very quiet today. Thumbs up? Yes. Thumbs down? No. Okay, cool. Okay. So let's quickly do that. Let's just see if I can get... Okay, are you seeing the new presentation that is session 3? Okay, cool. Okay, so let's go into this. So basically and I think you would have now seen when you did the assignments as well. The study unit 4 was basically, in a sense, explaining the concept of probability. Then the next set of study unit is looking at the discrete probability, and discrete is the normal discrete that we will see now. Then it can be Poisson and it can be binomial. And then the next set of probabilities will be your normal distribution, and then your next set is basically the square distribution. And in between that, we have confidence intervals and hypothesis testing and all those kind of things as well. So I think it's always important that we nearly start at the beginning to understand what is needed. So with discrete probability, and I think the important thing here is they can, and let me just first run through a few things. So they can give you a few nearly tables that shows the distribution functions. They can give you the table, and then they can ask you a few sets of questions, which can include probabilities. It can include nearly the mean that you need to calculate. They can give you the calculate or the table and ask you just to work out the mean. They can ask you again nearly a set of questions. The one that I excluded was the one to work out variance, because that will just take you forever to work that out. So they won't ask you in the exam to work out the variance for this probability function, because that will just take too long. They can ask you variance for Poisson distribution, because that's easier. They can ask you variance for binomial, and then for the normal distributions. Okay, so let's see, how do we, if we look at this, how do we pick up which one is wrong and which one is correct? What would your first way be to see what is right and what is wrong? Okay, so the clue with this one is, since we are only showing you the probability, it needs, the probability of all of those needs to add to 1. Perfect. So all of them needs to add to 1 to see which one. So basically, and this is just, I just normally scout through, so I'm skipping that one first because that feels too much work. I'll start with this one, 0.98 plus a 0.1 plus a 0.1 plus a 0.1, so it's not going to be that one. If I look at that one, 0.3, 0.4 is 0.7, 0.8, 0.9, it's not that one. Then I just want to first avoid numbers where there's too much. Okay, so this one, those two together is 0.5. So you can see I'm missing a 0.01. So it's also not that one. So that one added up to 0.99. That one added up to 1.01. That added up to 0.9. Okay, so let's look at this one. 0.4, those two together, plus that is 0.9, plus that is 1.2. Okay, so that is basically, must be the correct one. Okay, so that plus that gives me 0.52. That plus that gives me 0.39, 0.48. Sure. Okay, but you can also use a calculator, so don't, and that will give you 1. Okay, so that one is the correct one. So basically, you need to find with this one, which one adds up to 1, and that is your answer. Okay. Cool. So both of you were correct. Okay, so showing this, but I don't think it will be this easy in the exam. So I would, if it was me, I would have asked you something like this. So let's see what they are asking. Based on past experience, a researcher knows that the probability distribution for X is equal to the number of students who come to an office on Wednesdays is given as. Okay, so let's just make sure also that it adds up to 1. So 0.5, 0.7, 0.8. That is also 0.2. So it is at least adding up to 1. So which of the following statement is correct? Okay. I haven't seen that for quite some time. So let's see which ones are correct. So them saying X must be bigger or equal to 2. And I'm going to use a few different. So bigger or equal, let's see if that works. Bigger or equal to 2 basically means 2 and bigger. So if it's 2 and bigger, it is 0.5 plus 0.15 plus 0.0. So it will be 0.7. Okay, so that one is definitely wrong. Okay, so let's look at the next one. Smaller or equal to 1. Smaller or equal to 1. So basically, it is 1 and 0. And for 1 and 0, it is 0.3 and not 0.1. So that one is also wrong. Okay, let's look at, so I'm going to skip that one first. I'm going to going to look at the other two options first. So bigger than 1. So bigger than 1 does not include 1, but smaller or equal to 4. So it goes up until 4. So bigger than 1, smaller than and equal to 4. And we actually, so that and that one is exactly the same, which now you can see have been just written in two different formats. So that one will be the one that is correct. But quite interesting to see those two are basically written way differently, but you are actually working out the same answer. And then let's just do this last one. So bigger than 2, but smaller than 4. Bigger than 2, smaller than 4 is only that. So that will also be wrong. Okay, so if you needed to work out that, that would have been then to say 0 times 0.1 plus 1 times 0.2. So you will basically need to multiply those two every time and then add all of them together. So plus 2 times 0.5 plus 3 times 0.15 plus 4 times 0.5. And that will then definitely not give you that answer. So wait, let me just. It will not give you that answer. So that would have been 0. That would have been 0.2. That would have been 1.0. That would have been 0.45. Probably 1.85 that you're going to get. That is going to be 0.2. And then it's 1, yeah, your answer is going to be 1.85 and not 18.5. Okay. So this is normally where I see the questions going, is nearly giving you that table, give you a few probabilities to work out. If they want to, they can include the mean that you need to calculate, but it can just be also that you need to calculate all the probabilities. Okay, do you have questions on this one? Happiness that we can just continue to the next one, and let's see how far we get. Okay, so with this one, they give you the table and they ask you to work out the mean. Okay, so let's look at that. Sure, I'm just trying to see if I can nearly guess an answer, but it will probably not work. I would have said that one is maybe too big. But let's see. So I would have probably guessed between 3, 4, and 5. Okay, so what I would do is, okay, wait. Ask a question, Krishenda, if I pronounce your name correctly. You can unmute. Oh, no question. Okay, cool. So let's quickly, so what I would do with this one is I would not go and write somewhere else. I would just use this table. So I would just automatically say that times that gives me 0. That times that gives me 0.2. That times that gives me 0.2. That times that gives me 0.15. That gives me 0.12. 0.05. 0.06. So that gives me 0.4, 0.5, 0.55, 0.65, 0.67, 67, 677278. Okay, so that would have been your correct one if you added all of them together. Okay. The reason why I said not that one is because the biggest percentage is sitting with a 0. So that nearly tells me that the rest is going to be small. If that biggest percentage was sitting on this side, then because you multiply 6 by the 0.6, you automatically will then get a bigger number. Then I would have said, okay, I will start eliminating the smaller numbers. So that is just how I would have looked at it, and that's why I nearly from the start said I won't take that one because that's too big. I would probably go between those three. So again, it's just nearly a tip that I'm giving you. If you look where your biggest percentage is and you multiply that with the x, you nearly get a feel of which number it will be for your expected value. Okay, so I think the expected value one is great. The expected value one for me is a simple enough calculation. It does take time, but it's a simple enough calculation if it is just one question. So let's again look at some of these. So let's bigger than 1. So basically from 2 and above. So which one? So bigger than 1 is from 2 and above. So that is 0. So that one is correct. We are unfortunately looking for the incorrect one, so not that one yet. Okay, smaller or equal to 2. So smaller or equal to 2 is all of them. So that is 0.25, 0.65, 0. So that is also correct. Okay, so let's look at the next one. Bigger or equal to 1 and smaller or equal to 2. So basically it is 1 and 2. So it is 0.6. So that one is also correct. I'm running out of colors. Smaller than 1. Smaller than 1 is only that. So it is correct. Okay, so then go to bigger than 0, but not including 0. Bigger or, sorry, smaller or equal to 1. So basically only that one. They tell us it is 0.65. It should be 0.4. So that is the incorrect one. And this is nearly where your exam again is downloadable and things like that. Wait, no, it's not. See, so that for me is the difficulty with the stats one. It's not that you can go and now, like I did with with paper or with colors, try to eliminate things and highlight so that it's easier for you to see. So yeah, this again, the negativity, or not the negativity, but the downside to online exams is that you, how I like to do it on pen and paper is not available anymore. So you just need to nearly find another way of doing this for you. It does not say that you can't have a paper next to you and still write on it. Okay, so let's again here they ask us about the mean. So let's see. Yeah, you're right. You can do that as well. You can do that as well. See how it will, and you guys would probably have now received the email that said the assignment, or not the assignment, but study unit 11 is available to test on online. So that is how your exam will be set up. So your exam will be set up on that basis of you get a question, you click through to the next question. So that for me, and nearly play with all of the assessments that they're giving you a mark back in the end, but it's not counting for anything. It's more that you practice how it will be in the exam. Okay, so we've got a few minutes left, so let's see if I can at least finish with a discrete here, because the next one is binomial. So let's at least see. Okay, so first, for the mean, we will need to work out what that value is. So the other things that I'm looking at is, there's my biggest number. So 4 times 0.4 is already 1.6. So whatever else the rest is, it will be bigger than 1.6. So there I already have eliminated 2 options for you. So let's quickly see 0.2, 0.6, 0.8, 0.85. So that is 0.15. Okay, so that is 1.6. That is 0.6. That is 0.1. That is 1.0. Oh, that is 0.9. Okay, so we have 0.1, 0.9, so that is 1. We have another one. There we have 2.2. So we're sitting with 4.2. And we're sitting with the last one as your correct one. Okay, so again, nearly looking at where your biggest percentage was, multiplying that out, you could automatically say the first 2 is not even on my answer sheet. So if you needed to guess, then you can guess one of the others. But it's also nearly, out of these 3, one could have seen, okay, 1.6, 2.6, 3.5. So that already is also not one of the options, even before you start adding the rest. Okay, so that is your discrete distribution. So basically, the things that are important is if you can nearly see where the probabilities are. I think the important thing is to know if they say bigger than or bigger and equal to. I think that is the one that they normally try to catch you out is to use those signs. And then the other thing that they can ask you as well is working out the mean. They won't, I haven't seen in one of the exams that they ask you to work out the variance unless, not in a question like question 8. It can be like in a question like question 3 where there's variance as well. But when you do all the other questions instead of the variance one to find out if the variance one is correct or incorrect. Basically, you don't even go to work it out. You just make sure that you can get your answer for the others. So I, again, nearly want to give you that tip is the same what I did here was I calculated the other ones first because that's the easier ones to work out. And hopefully with that, I would find one that is correct. If all of them was incorrect, then I know the one that I didn't do is the correct one. So nearly again by elimination you can get there. We've got 4 minutes, so let's quickly, and I nearly want to show what I want, and we can just continue next week with this. But I just want to get the study guide. Where have I saved that? Because for the binomial and the Poisson, and let's maybe check, we can work out that mean and stuff like that for now. Okay, but what I will include for when we do this next week is I will include some of the binomial tables and the Poisson tables onto the questions so that we can just easier reference it, because I want nearly to work on all of these questions from the table so that you don't need to work with the formulas. So what I will do for next week, I will just include in all of these, I will include that the binomial and the Poisson tables. Okay, so that I will do for you for next week, and then we can continue next week. I think at least we still got nearly a month's time to run through everything, so we will have enough time to go through everything. And I will probably from next week or the week after, I will just make the sessions a bit longer as well. Okay, questions on your side, guys? Is this working? Is it helping? Is it assisting? Are you understanding it better? And you can unmute, you don't need to. Precious, is it at least helping you to understand?
Yes,
Okay.
it's helping.
Okay. Okay. So we will continue in this format and get to the other ones and in each one I will nearly give you some tips as well, what to look for and how to get things. Yeah. Cool. Just I think all of you are on the WhatsApp group. If you're not, give me a WhatsApp. Just send me a WhatsApp on 083-790-8387. Then I will add you, but I think all of you are. And then I will again just update the calendars. Do you get the invites in your calendars or not really? Do you get some of the invites or not really? But I just know if that function is working. Or do you just follow the links that I provide? Okay, cool. Okay, so that's fine. So I'll send the links again. I'll update on the time for next week when we'll have sessions, and I'll communicate that to you. I will say this again. I'll send it back to the group later tonight again, and hopefully the recording did happen. I just want to see what is wrong here and if there's something wrong with my teams at the moment. Okay, have a good evening, guys, and we'll chat again sometime next week. Okay, and please let's keep chatting on WhatsApp. Okay, have a good evening.